In my last video, I said I was going to search the bowels of the internet for the answers to my questions about biochar. Well, I searched and I just read Wikipedia, and then that wasn't good enough, so I read also a lot of articles, including scholarly journal articles, and I found the answers to my questions. So hopefully I can simplify that information enough to make it easy for anyone to understand, even though it actually was pretty hard to understand when I first read it. First, what makes biochar able to last for thousands of years? That answer to that is this structure. So this is called an aromatic ring structure and has nothing to do with aromas, but it's just the name for this. You can see that it's only black. Black means carbon, and then has some hydrogen on the outside edge. So because of this, it's difficult for microbes to be breaking down. They want to break down something that they can get some nutrients like nitrogen from, where this is just carbon. And in the burning process, there's oils that are produced. They're in the air, and then they condense back down again, and they're stuck, I guess, on the surfaces of these polyaromatic cyclic, anyway, these hexagons, and so the bacteria are actually just chewing on those slowly, and they prefer to chew on that slowly than to break down this. So this ends up staying there for thousands and thousands of years. But over time it does oxidize, and that's a fancy word, means to break down, and it tends to break down into different groups like these. So oxidize obviously involves oxygen, and this is called a carboxyl group, which has oxygen double bonded on here and then another oxygen here. And carboxyl groups are really common in nature, especially in different kinds of oils like butter and coconut oil and other oils. But these are on the surface of some of these hydrocarbons, and when they become deprotonated, which means that the hydrogen gets popped off, there becomes a space here which is a negative charge, and this negative charge is seeking some positive charged things. So if there's another organic molecule that is floating by or in the vicinity, it'll get associated with this molecule here. They're not going to exactly bond to each other, they'll be associated with each other. But this explains now how carbon in the soil from char then can double and continue to reproduce the amount of organic matter in the soil that is beyond itself, because it has these charged areas, and then more and more organic matter will tend to stick to it. In addition to this, also I was talking about those microbes that are living here and chewing on the oils. Those are living here and they're dying, and their dead bodies are breaking down partially and turning into some carbon dioxide, but a lot of their dead body is just staying here. I think around 40% is what I read somewhere. When they break something down, there's about 40% left as a long-term carbon compound. So then you get all this dead bodies and other organic molecules just all kind of sticking on to the outside of this very, very stable polycyclic aromatic compound, which is the carbon, the black carbon from the char. So that answers our first couple of questions. My next question was, then, if this is how it works, can I create the same situation on my farm with my biochar kiln? So I did some research, and I found out that if you burn char at a really low temperature, you have more of those oils. And if you burn at a very, very high temperature, you get less of those oils that the bacteria are just chewing on. The kilns that most of the people who are making biochar are kind of in the middle range, so around 600 degrees. Would that Fahrenheit or Celsius? 600 degrees Celsius is a mid-range, and so a lot of that oil is still being preserved and not totally burning up. And it seems to be that's the way that these soil scientists these enthusiasts are all using these certain types of kilns that have a mid-range burning temperature. So even though it seems like low temperature charcoal has more oil, which is supposed to be better according to what I'm reading, everyone's using the mid-range ones, so that's the kind of kiln I made too. And I'll show you some pictures of that.